In this video, we're going to take a look at one logarithmic differentiation problem. We're going to review the fact that the derivative of the natural log of u, where u is a function of x, is u prime over u. And then when we go to take the derivative, that we will be applying this. Alright, so if we've got a function f of x is equal to 1 plus 2x, quantity raised to the sign x here. Alright, this is an indication, yes, logarithmic differentiation is going to work really, really well for this. First thing I'm going to do is I'm going to take that f of x and I'm going to replace it with a y. So we'll have a y equals the 1 plus 2x raised to the sine x. Alright, now if you're going to do logarithmic differentiation, the point is to apply logs so you can make this a lot simpler expression, and then the derivative is going to be easier from doing that. So I'm going to take the log of both sides. I'm going to take the natural log of both sides. So natural log of y is equal to the natural log of the 1 plus 2x raised to the sine x. What this is going to allow us to do then is to take this sine x, bring it down in front because that's a log rule. So apply some logs, make the expression easier. So I'll have natural log of y is equal to sine x times natural log of 1 plus 2x. Alright, at this point I am ready to take the derivative. So I'm going to take the derivative to both sides. So d dx on this side, and then d dx on this side. Alright, over here it's just going to be a nice little product rule. Alright, and we've got this natural log in here where we will implement this derivative. Over here, again, we have the natural log of y, so we're going to apply this derivative rule as well. Okay, so this is going to become a y prime over y is equal to, we're going to do product rule here. So sine x, we'll leave the first one alone. We'll take the derivative of the second one. So I'm going to apply u prime over u. So derivative of the 1 plus 2x is just going to be a 2, so that goes in my numerator, and my whole entire u, that 1 plus 2x, goes on the bottom. So with that being a natural log function there, we can real easily take the derivative. Alright, plus, because we're still doing product rule, the second term, so natural log 1 plus 2x there, and then derivative of the sine is cosine x. Alright, now at this point we are trying to solve for y prime, so I'm going to multiply both sides by the y. It'll cross out on the left hand side. I'm going to multiply it then over here by y. Last step would be to take what we know is equal to y. Right here we said y is equal to this expression, so we can take that expression and plug that back in for y to get our final answer. So we're going to have a y prime is equal to, let's go ahead and multiply this, clean this up a little bit, 2 sine x all over a 1 plus 2x plus, let's go ahead and take this cosine x and move it in front. Alright, so cosine of x right here times the natural log of the 1 plus 2x. Alright, so nothing really new there, just doing some cleaning up here. Replacing this y with what it equals, we'll have a 1 plus 2x raised to the sine x. So a pretty straightforward logarithmic differentiation problem, and the whole point of choosing logarithmic differentiation here is once we apply some log rules to this original equation, it can be then a little simpler to take your derivative with that natural log function. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too, and don't forget to subscribe to the channel. Thanks.